8.3 Introduction to Probability. Random quantity that cannot be predicted exactly is known as random. Random experiment or random phenomenon has outcomes that we cannot predict, but that nonetheless have a regular distribution in a large number of repetitions. Trial. Each repetition is called a trial. Outcomes, possible results of each trial. Sample space, something we've already been using. And here's a definition. A random experiment is the set of all possible outcomes. Example. If we flip a coin, the outcome of heads and tails. But we do not know whether a particular flip will yield a head or a tail. But we do know that if we flip the coin enough times, approximately half the flips will be heads and half will be tails. Each flip of the coin is a trial, and the sample space is heads or tails denoted as S equals curly brackets heads tails. Okay. So, give the sample space for each random experiment. Use the spinner in figure A17. Okay. So for A, I have a sample space of 1, 2, 3, 4, 5, 6, and 7, which are all the possible outcomes. Okay? So B. For the purpose of public opinion poll, respondents are classified as young, middle age, or senior, and male and female. So, we have young, male, young, female, middle, male, middle, female, senior, male, senior, female. Okay? And C. For an experiment consisting of studying the number of boys and girls in families with exactly 3 children. So we're going to do this 3 times. So let's represent B for boys and G for girls. So remember the empty space, and then we have boy, girl. Then we have boy, girl. That's 2. Boy, girl. That's 3. And our sample space will be boy, boy, boy. And then boy, boy, girl. And then boy, girl, boy. And then boy, girl, girl. And then girl, boy, boy. And then girl, boy, girl. And then girl, girl, boy. And finally, girl, girl, girl. Event is an outcome or set of outcomes of a random experiment. Thus, an event is a subset of a sample space. Following our coin example, if the sample space head or tail, then E equals H. That means that the event is a subset of the sample space because we only have a head, which is one possible outcome. An ordinary fair die is a cube with 6, I repeat, 6 different faces show the following dots. 1, 2, 3, 4, 5, and 6. Fair means that it's not loaded in a way that a number appears more than other. Then the sample space should be 1, 2, 3, 4, and 5. For the sample space S, in the previous page, write the given events in set notation. So, we're going to be using the girls and the boy tree, I guess. So we have to do, the family has exactly two. So let's bring that back so it's better for us. Copy. Paste. Okay. So A. Event H. The three children are the same sex. So we have boy, 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 and girl, girl, girl. Sorry. Right, wrong. Sorry. Event H has two girls. So let's redo this one. Two girls. So no. Here's one with two girls. Here's another one with two girls. And here's the third one. So we have boy, girl, 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 boy, girl, and girl, girl, boy. B. For event K, all three children have the same sex, so that's simple. It's just our extremities. So boy, 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 girl, girl, girl. And for C, event J, the family has three girls. Girl, girl, girl. If an event E equals a sample space S, then E is a certain event. If event E is an empty set, then E is an impossible event. Okay? Suppose a fair die is rolled. Then the sample space is 1, 2, 3, 4, 5, 6. Find the requested event. The event, the die shows a 4. So for A, that's all because it shows a 4. That's our only possible answer. For B, the event, the number showing is less than 10, which is all of our possible outcomes because all possible outcomes go from 1 to 6. So for B, it's 1, 2, 3, 4, 5, and 6. And finally for C, the event, the die shows a 7, and that's going to be the empty set because our die goes from 1 to 6, leaving the 7 out. Since events are sets, we can use set operations to find unions, intersections, and complements of events. Okay, so we're back to what we were before. So, remember, let E and F be events for sample space S. Then E intersection F occurs when both E and F occur. E union F is when or both occur, and the complement does not occur. Okay? So, E complement, the student is under 20 years old. Well, let's first of all read the instruction. A study of college students grouped the students into various categories that can be interpreted as events when a student is selected at random. Consider the following events. The student is under 20 years old. So the complement, student is 20 years old and older. That would be the complement. B, F, G. So it says the student is male. And G is the student is a business major. So that's going to equal female students. And remember, intersection is and. So both have to occur and have a business major. And C, it's E complement union G. So the student must be under 20 years, so they must be older than 20 years. And the G is the student is a business major. So students with 20 years, so remember this is or. So this is a little bit tricky. No. Because of age wise, we can include all majors because E complement asks only for age. So E complement union G is equal to student with 20 years or older all majors included or business majors. Disjoint events, two events that cannot both occur at the same time, such as getting both a head or a tail on the same toss of coins. Okay? So, we have a sample space of 1, 2, 3, 4, 5. The sample space for tossing a die, let E equals 4, 5, 6, and let G equals 1, 2, 2, 3. Are E and G disjoint events? Yes. Because no outcomes in common occur. Therefore, E intersection G is empty set. And we can demonstrate this with a Venn diagram. So E, we have 4, 5, 6, and then we have G, that's strictly 1 and 2, and in my universe we still have the 3, so this is what we have. Now, probability of an event is a number that indicates the relative likelihood of the event. Basic probability principle, this is really important, okay? Important. Let S be a sample space or equally likely outcomes, and let event E be a subset of S. Then the probability that event E occurs is PE is equal to the number of E over number of the sample space. So let's see what the hell this means, okay? So A, suppose a single fair die is rolled with a sample space of, so remember our sample space is 1 through 6, give the probability of each of the following events. The die shows an even number. So P of E is equal to N of E. How many even numbers do we have in our sample space? Well, that's going to be 2, 4, 6, so that makes it 3 over all our sample space, which is 6, which makes it half. Now B, if the die shows a number less than 10. Again, we don't have a number bigger than 10. So that means all of our sample space is there. So P of F is equal to 6 over 6. So the possibility or the probability is 1, which equals 100%. So it's going to occur. Finally, C. The die shows an 8. Again, we don't have a number that reaches all the way to 8. So that's going to be 0 out of 6, which means 0. Okay? Now, please take a minute to hold the video, read all of this, and understand. Please. So I'm going to read it right now, but take your time and read it. A standard deck of 52 cards has 4 suites: hearts, clubs, diamonds, and spades, with 13 cards in each suite. The heart and diamonds are red, the spades and clubs are black. Each suite has an ace, a king, queen, jack, and cards numbered from 2 to 10. The jack, the queen, the king are also called face cards, and for many purposes can be thought of having values of 11, 12, and 13 respectively. The ace can be thought of as the low card 1 or the high card 14. See figures 8 through 820 will refer to the standard deck of cards, often in discussion and probability. So please take a minute to read this, understand it, swallow it, and come back once you're ready. So, if a single card is drawn at random from a standard well-shuffled 52-card deck, find the probability of each of the following events. So A, drawing an ace. Remember, we have 4 aces. Then we can say that this is 4 out of 52. Because we have 4 aces out of 52 cards. This can be simplified as 2 over 2 times 2 times 2 times 13, which equals 1 over 13. So the probability of us getting an ace is 1 out of 13. B, drawing a face card. Okay, face card. That's going to be jack, queen, kings. So that makes us 3 cards. But we have 4 suites. So that's going to make it 3 times 4. Therefore, we have a total of 12 face cards. Agreed? Therefore, our answer is 12 out of 52, which equals 4 times 3 over 4 times 13. There, our probability is 3 out of 13 that we're going to get a face card. C, drawing a spade. Well, we have 13 spades. Therefore, our probability is 13 out of 52, which that simplified will be into 1 times 13 over 13 times 4, which equals 1/4. And D, drawing a spade or a heart. So that's a little bit more interesting. Spade or heart. Okay? So we know we have 13 spades, and we also have 13 hearts. So we combine them, that's going to total of 26 possible cards, 26 possible outcomes. Then our probability is 26 out of 52, which is actually 2 times 13 over 2 times 2 times 13, which is 1/2. In the preceding examples, the probability for each event was a number between 0 and 1, inclusive. The same thing is true in general. Any event E is a subset of the sample space S. So 0 is less than or equal to the NE, which is less than or equal to the number of sample space. Since PE is equal to NE over NS, it follows that 0 is less than or equal to the probability of the event, which is less than 1. Relative frequent probability. We can estimate probability by determining the long-run proportion that an outcome of interest will occur given many reputations under identical independent circumstances. So this is what all this means. The General Social Survey picks U.S. residents at random and asks them for a great many questions. One of the questions that are asked respondents in 26: Do you feel your standard of living is much better, somewhat better, about the same, somewhat worse, or much worse than your parents? The table categorizes the response. Okay? So, estimate the probability of U.S. residents feel his or her standard of living is much better than that of his parents. Well, before answering that, we need to find our sample space. To do that, we're going to add everything together. And that equals 1,932. Now we can answer our questions. So, much better than his or her parents. Much better, so that's right there. So PA is equal to 573 over 1932. If we divide that using a calculator or by hand, we have a probability of 0.2966 or 29.66%. B. Estimate the probability of the event to be, so probability B, that a U.S. resident feels that his or her standard of living is somewhat worse or much worse. Somewhat worse or much worse. So that's going to give me 238 because that's for somewhat worse, plus 100 because that's much worse, all over 1932. So that's going to give me 338 over 1932, which approximates to 1749. Okay? Properties of probability. Let S be a sample space consisting of n distinct outcomes S1 through S2 to S2n, an acceptable probability assignment consisting of assigning to each outcome Si a number Pi, the probability of Si according to the following rules. The probability of each outcome is a number between 0 and 1. We already showed that. The sum of probability of all possible outcomes is 1, which we already showed before. Okay, so this is just properties that we already demonstrated. And this actually concludes what section? I believe it's 8.3. Yep, we're done with 8.3.